Standard form is where we are starting. Just like the parabola had a standard form and the circle had a standard form, an ellipse has a standard form. Okay, are we ready? It is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Now, they will not always be in standard form. So when they are not in standard form, how do you recognize what it is? I'm going to repeat that. It's not always going to be in standard form. At times it might be in expanded form. So when it's in expanded form, how can you tell what shape it is? First off, parabolas are the only ones with 1 squared. Does this have 1 squared or 2 squared? 2 squared. What are the shapes so far also had 2 squares? Circle. So how is this going to be different from a circle? Do you see that there's still a plus here and they're still both positive? Even though they're at the bottom, they still count as the leading coefficients. They will be different or same? Different. So if you had it in expanded form, like when we had the circles, let's see if I can find one. Here's one here. It would look just like this, but instead of these two being the same, this might be 9 and this might be 16. Make sense? The leading coefficients would no longer be the same. Other than that, it's going to look very similar. Why does it look so similar? Because an ellipse is very similar to a circle. What's the difference? It's longer going one way instead of like up 5, down 5, right 5, left 5. It's stretched out one way more than the other. Yes? All right, and that's why the coefficients. That's what makes it different, because those coefficients are different. One, it gets stretched out one way more than the other. All right. Center. Is still HK. Now, with the parabolas, we kept saying opposite of the inside, outside stays the same. There are 2 insides here, so it's opposite of both insides. Opposite of negative h, opposite of negative k. HK. The only one where its outside stays the same is a parabola, because a parabola is the only one with 1 squared. All right. I'm going to just draw some pictures and get you an idea of the vocabulary and what we're going to have. They will always have a center, and the endpoints that are the furthest away, because you're going to go up from the center, you're going to go up and down, right and left, up and down, right and left. The points that are furthest apart are called your vertices. And what did I just say about vertices? They are what? Always furthest apart. Or always, I'm going to put it with a different word, always on the major axis. Does that ring a bell from last year? No? Major axis. Major axis is exactly what I just said. It's the 2 points that are furthest apart. So this major axis runs horizontally or vertically, the one I'm pointing to. And this major axis runs vertically. And the vertices are always the 2 points furthest apart, which means it's always on the major axis. All right, questions on that? All right, next thing I'm going to draw, still the ellipse, but this time I'm going to show you what the foci look like. Does anybody remember what the foci look like? Where they're at? And I say foci, and I didn't even explain. We've dealt with the focus, the focus, the focus. Circles don't have a focus. We don't name it. It's just the circle, the center, and the radius. Parabolas have a focus, and I changed the word focus to foci. Some of you may call it foci. We don't say focuses. Foci or foci, your choice. It's plural. Plural meaning more than one. There are 2. Yeah, no focuses. Foci or foci, depending on how you want to say it. Oh, wrong one. They're always going to look like this or this. Okay, so just like the vertices, they're always on the major axis. Do you see that? Just like the vertices, they're always on the major axis. So let's write that down. Foci or foci are always on the major axis. And always what would we say? Where do they exist? Always inside or outside of the ellipse? And I'm going to say inside of the vertices. Always inside. Oh, we'll just say ellipse. Always inside the vertices, always inside the ellipse. All right. Questions on foci or vertices? Okay, just like with the parabola, we had a focal length. We still have a focal length. And it is f squared equals the absolute value of a squared minus b squared. All right. A few things you should recognize. Where are the a squared, b squared coming from? These guys right here. Yeah, the standard form, the denominator of the standard form. Why absolute value? Because we're going to square root both sides to solve for f. And when we square root, can we square root a negative when we're dealing with length? No. So we take the opposite value because when you're subtracting two numbers, there's a chance it might be negative. Make sense? Questions? None? All right. Another piece that I'm not sure if you dealt with last year, and it's called the eccentricity. No? All right. What does eccentricity tell you? Well, first off, it's f over a or f over b, depending on which one is larger. So make note here. Why am I frozen? Okay. Make note here that the a squared b squared in the focal length formula is a squared b squared. But when you use it in your eccentricity formula, it's just a or b. Or, not and, or. It's going to be either whatever f is over a or whatever f is over b. How do you know which one to use? The bigger one, the larger value. All right, questions. All right, questions are going to ask you on the test about eccentricity. They will ask you to find it. But not only will they ask you to find it, they're going to ask you to use it to describe your ellipse. All right, so let's write down. First off, eccentricity will always be between 0 and 1. Eccentricity is always between 0 and 1. That means it's never going to be negative, which makes sense because f, when you take the square root, is always going to be positive. A and b are always going to be positive. Eccentricity is always positive. What positive numbers are between 0 and 1? A half, third, 2 over 5. All right. Now, this is the type of what you need to know. The smaller your eccentricity is, the closer to 0 it is, your shape is going to be more of a circle, more circular. The larger your eccentricity is, the closer it is to 1, the more oval your ellipse is going to be. So they'll ask you on a test, which eccentricity is closest to a circle? And you would pick the larger or smaller? Smaller. Make sense? Yep. And make sure that's smaller, but not just smaller, but between 0 and 1. No negatives. Okay. Are we good? All right. Examples. Find the center vertices, foci, eccentricity, and sketch. Sorry, that is just a mess. One more time. All right. All right, number 1. X minus 2 over 9 plus y minus 1 over 4. And I'm going to put squares here on both of them. And then equals 1. All right, I'm going to put C for center. What is the center? Opposite? 2 and what? 2 and 1. All right, so let's at least get that done. All right. Does anybody remember what you do next to figure, like if it was a circle, we would find the radius and go up and down the length of the radius. In this case, what do I do? Does anybody remember? These numbers right here tell us the right and left movement. What is the value, if a squared is 9, what is the value of a? 3. If b squared is 4, what's the value of b? 2. All right, so we're going to go right and left one of these and up and down the other one. And you can see because they're not the same, it's not a circle. Yes? Can anybody answer how we got these numbers? Square root the denominators. A squared is the one underneath the x squared, and b squared is underneath the y squared. So if a squared is 9, a is 3. If b squared is 4, then b is 2. Okay. So we move right and left and up and down. Now, which one's right and left? Which one's up and down? Think of your x. Which way does your x-axis run? Left and right. Which way does your y-axis run? Okay, so this one, the 3 is going to be going which direction? Left and right and left. And the y value is going to be going up and down. So we go right 3, 1, 2, 3, 1, 2, 3. What was that? Because the 3 is coming from the 9, correct? And the 9's coming from the x, and the x-axis runs right and left. And the 2's coming from the 4, and then 2 up and down. And then you make your ellipse. A little before your time, but I always think of Hey Arnold when I graph these. I guess you guys are more, what's his name? Stewie? Yeah. All right. So, next thing we're going to list are the vertices. Now, I have a few points here. Besides my center, I have the 2 points that I went up in the up and right direction and the 2 points going in the right and left direction. Which 2 are the vertices? The 2 right and left or the 2 up and down? Is it always going to be the 2 right and left? No, but it will always be the 2 that are furthest apart. So this is a vertex and this is a vertex, so your vertices, for plural, not vertexes. Is vertici? No. Versi. All right, so what's this one here? -1 up 2. And this one here is that 5? And sorry, up 1. Thank you. 5 up what? 1. All right. -1 up 1 and 5 up 1. Does everybody see that? Yes? All right. Foci. Foci is where it gets a little tricky, so I need everybody paying attention. First off, Which direction am I going to run for my foci? Right and left or up and down? Right and left. Why? Because this is the major axis and everything runs on the major axis, your vertices and your foci. All right, how far right and left am I going to move? F squared equals the absolute value of a squared minus b squared. So 9 minus what? 4. F equals the square root, because I square root both sides. What's 9 minus 4, or the absolute value of 9 minus 4? Root 5. All right. Now, focal length is root 5. Does anybody know what root 5 is? A little bigger than what? 2, because 5 is bigger than 4, and the square root of 4 is 2. So it's a little bigger than 2. So 1, 2, a little bit bigger. 1, 2, a little bit bigger. And there are my foci. Now, you don't need to know exactly, you don't need, as long as they're inside and it's right and left. Now, how do we write that for the foci? You're not going to use decimals. It's going to be really easy. You just have to remember how to do it. All right, are we ready?
Yeah.
Just like with the parabolas when we did the focus and I asked you which value is changing, same question. When I run right and left from the center and everything's moving from the center, when I move right and left from the center, which value is changing, the x value or the y value? The x. Do you see that's why it changed here and here?
Yeah.
But what stayed the same? And the y value would still stay the same. All right, when I run right and left from the center, how far right and left am I moving? So I'm plussing root 5. Remember when we did that in our notes the other day? And I'm subtracting root 5 from what number? The 2. So I'm going to do 2 plus root 5 and 2 minus root 5. I'm not going to calculate it, but do you guys agree? When I move to the right, which one is this one? 2 plus or 2 minus?
Plus.
That's 2 plus root 5, and this one here is 2, and you write it like this. 2 plus or minus root 5, comma, what's still the y value? 1, because the y value has stayed the same all the way through. All right, and that's how you will write it on the test. That's how you will write it on homework. Okay, now vertices have 2 ordered pairs, but foci looks like it's only 1. Is there 1 or 2 in disguise? 2 in disguise. The 2 plus root 5, comma 1, and the 2 minus root 5, comma 1. Yes?
I'm confused how you graphed them.
How we knew where they were?
Yeah.
Gabe and a few others said it was close to 2, and you don't need to know exact. You can plug it in your calculator, but they know the square root of 4 is 2,
Yeah.
so square root of 5 is a little bit bigger than 2. And not quite 3, because 3 squared is 9, and it's not, 5 is not big enough to be close to 9. Does that make sense? So they just said a little bit bigger than 2. And if you plugged it in your calculator, it would come out to be pretty close. Let's see. It gave me root 5. All right, let me try again. Square root 2.2. I don't know if you can see it in there. Maybe not. Yeah. Yeah. Okay. Questions? Oh, what did I not find? I'm going to use E for eccentricity. And you will need a decimal value. I didn't tell you guys to get calculators out, so I'll give it to you today. But it's going to be F, which is what? Root 5 divided by A or B, depending on which one is larger. Now, which one's larger? A. Do I use the 9 or the 3? 3. Know when you're using the squared values and when you're using the square rooted values. It is F over A, not A squared, and A is 3. All right, you would plug that in your calculator, and I'm going to put approximately equals to 0.75. Got it? Questions? And I plugged it in there. You can see it. It's 0.745. Maybe you can't see it. All right. Are we good? Yes.
How'd you get the root 5?
It came from, the formula is F over A, and F was root 5 right here.
Oh, okay.
Do you remember when we did that earlier? Yeah. It was the focal length. Okay, questions before I move on. All right, number 2. I'm going to let you guys try number 2 on your own as fast as you can. Oh, I don't like this one already. All right, why is this one a little like not as nice? The fraction. Okay, still doable. We're just gonna make our graph a little bit bigger because we can still take the square roots. A squared is 1/4, so you square root it. What is A? 1/2. B squared is 1. Square root it. What is B? 1. All right, what's your center? All right, now when I graph it, I'm going to put it down in quadrant 3. And I'm going to make my spacing of my numbers really big so that I could fit the half in there easily. All right, -2, down 4. Do you guys agree that's where we would be? All right, right and left is whatever the square root underneath the A. 1/4 is underneath the X. X-axis is right and left. What's the square root of 1/4? So I'm going to move right and left how far? A half. So not that bad. Up and down is the y-axis, and underneath the y is 1. What's the square root of 1? So I'm going to move which direction? Up and down 1, yes? Okay. Still doable. Can anybody tell me which way the major axis is running for this one? Up and down or right and left? Can everybody see that it's up and down? Yes? All right, so when I find the vertices, will I use these 2 dots that I'm pointing to, the right and left dots, or these 2 that I'm pointing to, the up and down dots? So can you guys find that right now? It's left 2 down something and left 2 down something. And there will be some numbers in there. What is it? -2, -3, and -2, -5. Any questions on that? What value is staying the same on this one? Earlier it was the y. Why was the y staying the same? Because everything was moving left and right. This time we're moving up and down, so the x is staying the same and the y is changing. Do you see that? Yeah. All right, what else do I have left? Foci. In order to find the foci or even the eccentricity, I need to first find the focal length. F squared equals the absolute value of a squared minus b squared. What's a squared? 1/4 minus 1. And f equals the square root. Can you guys do it in your head? What's 1/4? Take away 1/4, and it's take the absolute value. Okay, so squared, I'll leave that in there. Absolute value of -3/4, yes? Square root of +3/4, root 3 over what? Now, I said already you don't have to plug in the foci. You just have to put it in there in the right form. Now, one of these is staying the same, and one of them is going to have the plus and minus. If I'm moving up and down, what is changing? Y, which means the x is going to stay the same, which we already anticipated. All right, and then the y value is -4 plus and minus what? Root 3 over 2. All right, your foci will always look like this. Your x or your y value will stay the same from your center, And your x or your y value will have the plus or minus piece on it. Always, everything from the center. Make sense? And we did the same thing here. We just don't write it that way because we don't need to. But how far up and down did we move again? 1. So we really did -4 plus or minus 1. What's -4 plus 1? -3. What's -4 minus 1? We just don't have to write it that way because we have our graph and we can visually see it. But does that make sense? Yes?
Can you repeat what you were saying? The center comes, you were saying like the
Uh-huh. Everything comes from the center, your vertices and your foci. Like I just showed you right now, the vertices. So the center, you figure out what's staying the same, the x value, and the y value is changing. When we went up and down, it was -4 up 1 and down 1. And -4 plus 1 is the -3, and -4 minus 1 is the -5. When I went up and down for the foci, it's √3/2. Can't clean that up as nice as I could on this one, so we just write it like this. It all comes, everything comes from the center. And that you will need to remember. That's true for ellipses and hyperbolas. That'll be tomorrow, Friday. All right, eccentricity is f, which is our f is √3/2, divided by the larger. What's larger, 1/2 or 1? 1. And you plug it in your calculator, which I'm going to do for you now. It's 0.87. You want a decimal because you're going to be comparing eventually, like which one's more circular, which one's more oval. All right, questions? Okay, this next one, all I want you to do is just write in descriptive form, just so we have the practice. X squared plus 4y squared minus 6y plus 20y, take away 2 equals 0. All right. And we're going to go fast because we are running out of time. So like we complete the square for the, first off, I forgot to tell you this. You're taking the test, you get this shape. How do you know what the name of this shape is? X squared, y squared, these two are not. Thank you for catching that, and let me look at my problem. That there should be an X. Did I say an X and write a Y? Did I say Y? Who knows? Well, some of you write as I'm saying. Okay, thank you for catching that. But you're taking the test, and they ask you to name the shape. The first shape you should always look for is starts with a P. Parabola, because that's the only one that has one squared. Is there any way this is a parabola? No, because there's 2 squares. All right, circle or an ellipse. Circles, okay, they're both positive, that's good. But circles have what? Same leading coefficients. Are these the same? Which means it's not a circle, it is an ellipse. All right, so let's regroup just like we did before. X squared minus 6x plus 4y squared plus 20y equals, and I move that over, 2. Now I'm going to complete the square here, and I'm going to complete the square there. We've talked before about not having a leading coefficient. Does this one have a leading coefficient? No, so I can go straight to x squared minus 6x plus blank. Does this one have a leading coefficient? And I have to factor that out. Not the GCF, just the leading coefficient. So it's 4y squared plus what? 5y plus blank. Now, why on this one did I have to worry about this 4 first? Because it had a leading coefficient where this one did not. Do you see that? And there's a plus right in there. All right. Take your 6, cut in half and square it. Bless you. What do you get? 9. Take the 5 as a fraction, cut in half and square it. Don't change the decimal. It's 25 over 4. Kids freak out when they have this. I know you had one like this on homework a while back. If you haven't seen it, maybe go back and look because it was there somewhere. You cut in half and square it. Just leave it as a fraction. It's easier. All right. Plus blank, plus blank. What goes in my first blank? This one? Because there's nothing outside to multiply, right? But this one, should I put 25 over 4? I should not. I multiply, and that works out nicely. What happens? The 4's cross out, yes? All right, so double bubble. X and X, minus and minus. What's the number? 3. y and y plus and plus. What times what is 25 over 4? And it has to be a perfect square. Like it has to break down to square root it is what I'm saying. What is it? 5 over 2 and 5 over 2. And what's 5 halves? If you did FOIL this out, what's 5 halves plus 5 halves? 10 over 2, which is 5, and is at the middle.
Yeah.
All right. Equals, anybody know what this is? 36. All right, x minus 3 quantity squared plus 4 y plus 5 halves quantity squared. I will not ask you to graph this one. I mean, you could technically. Now, am I done? No, because I have to divide everything by what? 36. If it was a circle, I could leave it 36, but if it's an ellipse, it has to equal 1. And that's a big fat 1 in disguise, and then you just leave this as x minus 3 squared over 36. And then you reduce this one, what goes into 4 and 36? So that's 1, and this is 9. Y plus 5 halves squared over 9 equals 1. And that is your descriptive form, a typical test question. Questions?